Morning, my name is Luisa Rios from La Salle University, and I will explain about impact of accelerated climatic again on the behavior of gypsum plasterstraw material for the construction of thermal insulation. Introduction. This paper investigates the long-term durability under changing climatic conditions of straw material gypsum for the construction of thermal insulation. Underwent acceleration tests by freezing, thawing, and drying by wetting to simulate outdoor conditions. Two compositions of straw and gypsum were designated. The second is methodology. Accelerated gain methods are needed to estimate the long-term maintenance potential of building materials under the environmental conditions of use. Manufacture of samples. In the first method, the fibers were used their initial leg in straw bottles. After wetting the straw fibers in the mixer with 1/3 of the weather calculated from the WB radio for 60 seconds, the gypsum powder was added and mixed for 60 seconds with the remaining water due to the length of the fiber. This resulted in mixing difficulties with poor composite block result. The second method consists of first grinding the fibers and then mixing them with the plaster in the same way before. This procedure with weak and brittle blocks with a number of problems such as the absence of binder between the fibers and the segregation the plaster in the lower part of the mold. Manufacturing of composite blocks with problems. A is advance of fiber binder. B is the segregation of the plaster in the bottom of the mold. Finally, method adopted. This procedure consists in first mixing the straw fibers with the 15% of the water for 60 seconds, followed by the addition of the blender water mixture and the mixture for 5 minutes. The blender was mixed with 85% of the water prior to addition in the mixer in the order to obtain a good blender fiber blend. Technical test. The durability of composite of gypsum of straw was evaluated by mechanical and thermal tests of compression at the end of 5, 20, and 40 cycles. The thermal conductivity was measured by a thermal conductivity meter, an EOTIM FP2C apparatus using the hot wire technique. Second is the mechanical was performed with a compression test machine, IGM 250, equipped with a 25 kilonewtons load cell in the casting direction of the material, since the direction had less dispersion in the results. Finally, is the results and conclusions. The first is for the VP material. A slight difference was observed in the layers deformation. This decrease is stress is due to the latching of the binder on the straw surface due to the immersion of the specimen. It can be concluded that the wet-based material is more durable and resistant than the VP compound. The gain process was stopped at 35 cycles for the barley-based compound in view of the significant loss of mass of microporosity. The result of this exploratory work led to the conclusion that the freeze-thaw conditions used have only a slight effect on the behavior of the composite material, and that the significant change in the properties is due to again by weathering. Barley-based material has better properties in the unaged state but loses yields under long-term conditions. The greater capacity of barley straws to absorb moisture is the main disadvantage for the final compound.